Sign diagrams. This is a relatively simple concept, but an important one. And it ties in with what we've discussed about the modulus function. Consider plotting the function below. We can see that this is -8, -2, -7, 0, -3, 10, 3, 4, 10, -2, 14, 0, and we've got 15, 8 up here, and then 7, 0 here. Now I want you to look carefully at the y coordinates of these points. So -2, 0, 10, 4, 0, -2, 0, and 8. When plotting the curve, points with a negative y-coordinate are plotted below the x-axis. We can see that here with the -2, -2 here. Points with a positive y-coordinate are plotted above the x-axis, so the 10, the 4, and the 8. Points with a 0 y-coordinate are plotted on the x-axis, -7, 0, 7, 0, and 14, 0. And none of that should be news to you at all. So, here we have the same curve with those points shown. Consider the sign diagram for this graph. So what we draw is just an x-axis. And then at -7, we have an x-intercept. We have another x-intercept at 7. That's where the graph crosses the x-axis. And we also have one at 14. To the left of -7, we can see that the curve is below the axis. In other words, the y-coordinates are negative. So we just put a negative. In between -7 and 7, we can see that the curve is above the axis, which means the y-coordinates would all be positive. So we just indicate this with a plus. Then between 7 and 14, once again the curve is below the axis, so that's a negative. From 14 onwards, it's above the axis, so that's a positive. And this is the sign diagram for this graph. So let's look at a slightly more complex graph. This one has asymptotes. This is a function for which we cannot substitute in the number -5 or the number 2. And the curve goes off to infinity, or -infinity, along this line, the line x equals -5, and also along x equals 2. Those are called asymptotes. Now, just think about the domain for this function. The domain for this function would be the set of values x. X belongs to reals. X is not equal to -5. X is not equal to 2. Now, let's look at the sign diagram. So we need to draw an axis. We can see that the sign changes at -5, but to indicate that that's an asymptote, we'd do a little dashed line here above. There's a 0 here, and we've seen how the zeros are indicated before. And then we'll have another dashed line to indicate the asymptote just here. To the left of this asymptote is negative. It's positive in between the asymptote and the root or 0 of the function. Then it's negative between the root and the next asymptote, and then positive. Now we should also state the values at which these happen. So this asymptote is at -5, this one's at 2, and the 0 of the function is when x is equal to 0. Now consider y equals x plus 3 times x minus 2. I can see that there's a 0 when x is negative 3. And another 0 when x is equal to 2. Now, it's not really necessary here, but when you get more complicated functions, this can be useful. So I've got the functions x plus 3 and x minus 2. Now, this one had a 0 at negative 3. So we'll look at what happens for x is less than negative 3. This one has a 0 at 2, so let's look at what happens between negative 3 and 2. And this one 0 is at 2, so let's look at what happens if x is more than 2. So if x is less than negative 3, say negative 4, this is negative and this is negative. So they're both negative. And that means negative times the negative, overall the function is positive. If we're in between here, say 0, this one is positive. 0 take away 2, that one's negative. Then we're doing a positive times a negative, which gives us a negative. And if x is more than 2, let's say 4. 4 plus 3 is 7, that's positive. 4 take away 2 is 2, which is positive. Positive times positive gives us a positive. Let's just get rid of that. And so we can say that it's positive here, negative here, and positive here. Now this function is a bit more complicated because here we have denominator of x plus 2, x minus 3. This one has a 0 when x is equal to negative 2. But because that 0 is on the bottom, we're dividing by 0. That's going to give us an asymptote. And the same sort of thing at x equals 3. The top becomes 0 if x is equal to 1. So that's a 0 of the function because 0 divided by something is just 0, but what we can't do is divide by 0. So it's when you're dividing by 0 that you get asymptotes. Let's do this sort of analysis for these. So the first one that would change was x plus 2, then the x minus 1, because we've got negative 2, then 1, then 3, and then the x minus 3. And then we'll have the overall function below. So we're looking at when x is before negative 2, when x is between negative 2 and 1, when x is between 1 and 3, and when x goes beyond 3. So just choose something that's to the left of negative 2, like negative 3. Every single one of these is negative. Between negative 2 and 1, this one has now become positive, and these are still negative. Between 1 and 3, the first two are positive. Just choose 2, for example. This would be 4, this would be 1. This is still negative 1. And then as soon as we're more than 3, they're all positive. Now we're just multiplying or dividing. So negative times negative times negative is negative. This one would be positive. This one will be negative. This one will be positive. And so we can do our sign diagram. Now remember, the first one that changes is the negative 2, and that's an asymptote. The next change is at 1, and that's actually a 0 or root of the function. And then the next change is at 3, and the x minus 3 is on the bottom, so that's also an asymptote. And then we have negative, positive, negative, positive.